Welcome to the Explainer. So, you want to know the actual future of mobility? Well, you are absolutely in the right place. Today, we're going to totally shift your paradigm when it comes to electric vehicles, range, and what truly makes an EV great. We're cutting through all that marketing fluff to look purely at the data and uncover the real story behind electric vehicle efficiency. Let's just kick things off with a slightly provocative question to challenge a really common myth. Does more range actually mean you need a bigger battery? For the longest time, the assumption in the car world has been that if you want to drive further, you just have to strap a massive, incredibly heavy battery pack to the floor of the vehicle. But as we'll see today, the smartest engineering out there is proving that assumption completely wrong.
Okay, here's our roadmap for this explainer. 1. Beyond the battery size. 2. Measuring electric efficiency. 3. Real-world road tests. 4. Factors draining your charge. 5. The true cost of driving. And finally, 6. The surprising city paradox.
Section 1. Beyond the battery size. The EV paradigm shift. There's this pervasive myth right now, this idea that a bigger battery automatically equals a better car. And because consumers have been leaning toward larger, heavier vehicles like SUVs and trucks, average EV efficiency has actually gone down since it peaked back in 2018. But the reality? Maximizing efficiency through sleek aerodynamics and strict weight management, that is the true pinnacle of electric vehicle capability. Moving right along to Section 2, measuring electric efficiency, understanding the jargon. To really appreciate the engineering marvels we're about to look at, we've got to understand the metrics that actually matter. Did you know an electric motor operates at a staggering 90% efficiency? That is huge. To put it in perspective, a traditional gas engine is incredibly wasteful, hovering at only about 30 to 40% efficiency, because most of its energy is completely lost as heat. Electric motors just absolutely destroy that metric. So because the mechanical systems are basically apples and oranges, we use a metric called MPGE to make comparing EVs and gas cars much easier. It's an EPA rating showing how many miles an EV can travel using the equivalent energy of just one single gallon of gasoline. So if a car is rated at 132 mpge, it means it's traveling 132 miles on the energy equivalent of 1 gallon of gas. Let's anchor this in something super relatable. Think of 1 kilowatt-hour of battery capacity as being roughly the same as just 0.1 liters of gasoline. It's literally just a tiny splash of fuel, yet an efficient electric vehicle can do absolute wonders with that tiny little splash, as we are about to see.
All right, Section 3, real-world road tests. The proof is in the data.
This is where theory actually meets the pavement. Looking at Recurrent's 2026 EPA data, we can clearly spot the top 3 most efficient EVs. The Lucid Air luxury sedan just dominates the pack with an incredible 146.5 mpge. It's followed closely by the highly aerodynamic Hyundai Ioniq 6 and the Tesla Model 3, which are actually tied at a really impressive 134.8 mpge. This data definitively proves that advanced powertrains and lightweight engineering win the day. Let's take it even further. Motor One did this grueling, independent, real-world test on the Rome Ring Road. We're talking real traffic, air conditioning blasting, the whole shebang. And look at this. The Mercedes CLA traveled 577 kilometers. That is only 9 kilometers less than the BMW iX3. Why is that mind-blowing? Because the Mercedes did it with a battery that's over 20 kilowatt-hours smaller. Its superior aerodynamics completely neutralized the BMW's massive battery advantage. We also see the Tesla Model Y pulling an impressive 495 kilometers on just a 77 kilowatt-hour battery. Which brings us to Section 4, factors draining your charge, the variables. So, if your range isn't just dictated by battery size, what's actually eating up your charge out there on the road? Well, there are basically 4 main culprits. First up is weight. Heavier vehicles simply need more raw energy to move. Second is aerodynamics. Tall, boxy SUVs have way more drag than sleek sedans. Third is temperature. Cold weather, specifically below 5 degrees Celsius, actually physically slows down the lithium cell chemistry. And finally, your driving style. Aggressive acceleration and sustained high speeds just waste a tremendous amount of power. Let's compare 2 totally different vehicles. On one side, the Lancia Ypson, weighing a modest 1,561 kilograms, hitting a fantastic efficiency of 6.3 kilometers per kilowatt-hour. Contrast that directly with the taller, heavier Smart #1 crossover at 1,820 kilograms, which only manages 4.6 kilometers per kilowatt-hour. That efficiency gap translates to almost 90 kilometers of extra range for the Lancia on a standard 50 kilowatt-hour battery, simply because it respects the rules of weight and aerodynamics.
Moving to Section 5, the true cost of driving. The bottom line? Because let's be real, efficiency isn't just some cool engineering flex. It's a financial strategy. The economic advantage of an efficient EV is just undeniable. Whether you're charging at home for around 4 to 6 euros per 100 kilometers or using a fast charging app subscription for under 5 euros, the savings are massive. Compare that to spending well over 10 euros for every 100 kilometers in a gas car. We're talking about 45 to 60% savings on your driving costs. And as we wrap up this explainer, I promise to leave you with a fascinating new insight that completely flips traditional car logic on its head. So here it is, Section 6, the surprising city paradox, a final nugget. The efficiency dynamic of an electric vehicle is the exact opposite of a gas car. We all know gas cars are absolutely terrible in stop-and-go city traffic, right? But they hit their stride cruising on the highway. Electric vehicles are completely different. They're incredibly efficient in the city, but they lose range rapidly on the highway because pushing a car through the air at 130 kilometers per hour creates exponential aerodynamic drag. The reason EVs basically rule the urban jungle comes down to a really brilliant two-step process. Step 1 is regenerative braking. Instead of wasting energy as heat on your brake pads like gas cars do, an EV actually captures it. In stop-and-go traffic, you're constantly putting charge back into the battery every time you slow down. Step 2 is reduced wind resistance. At slower city speeds, the battery doesn't have to fight the air, which saves massive amounts of power. As our sources point out, these factors actually help EVs get about 15 to 25% better mileage in the city than on highways, which, again, is totally the opposite of what happens with gas cars. So if you're mostly a city driver, an electric vehicle is mathematically and practically your ultimate efficiency weapon. Thank you so much to all you Focus learners for joining this explainer. We covered a ton of ground today, and I think we proved definitively that just buying a bigger battery isn't always the answer, and that smart aerodynamic engineering is the real key to better range and keeping money in your pocket. So, what efficiency myths should we bust next? We can't wait to have you join us next time to uncover more fascinating truths.